Hello students, welcome to BTech first year physics course. In the last lecture, I have discussed about Stokes theorem and concept of curl, right? Now today, I shall discuss two problems and their solutions related to Stokes theorem to show you how you can apply Stokes theorem. Okay, so let's start with first problem, and that is we have to evaluate closed line integral f dot dr using Stokes theorem, where f is of this form: y square I cap plus x square j cap minus x plus z k cap, and c is the boundary of the triangle with vertices at 0 0 0, 1 0 0 and 1 1 0, which is shown over here. And here you can see the direction of the closed path is anti-clockwise or positive in direction, right? Now according to Stokes theorem, you know closed line integral f dot dr is equal to surface integral curl f. So to find out closed line integral f dot dr, we can use Stokes theorem, and for that we have to calculate curl of f. And if we do the calculation, we get this value j cap plus 2 into x minus y k cap. Now this is very straightforward calculation. You know how to operate curl on a vector field, right? So in this way, if you do, then you can reach here. Okay. Now we have to find out curl f dot n cap. So to do that, we have to know what is n cap, right? And here you can see the z coordinate of each vertices of the triangle is 0. Therefore, we can tell the triangle lies in xy plane. Hence, n cap is actually k cap. Thus, curl f dot n cap takes this form: 2 into x minus y. Right? Now, there is a particular relation between y and x, which will help us to find out the surface integral, and the relation is y equal to x, which is this part of the curve, right? And you know this is the equation of straight line y equal to x, where m equal to 1. Then the surface integral can be written like this form. Now here x varies from 0 to 1, which we can see from this figure, and y varies from 0 to x, because at a particular x distance the upper limit of y will be according to y equal to x relation, right? So first we have to do the integration with respect to y from 0 to x, and we get this integrand x square minus x square by 2. So from here x square by 2. Then after doing the integration with respect to x and putting the limits, we get this value 1 by 3, right? Next, let's discuss another problem. Here you have to verify Stokes theorem for this vector field. A equal to 2x minus y I cap minus y z square j cap minus y square z k cap, where S is the upper half of this sphere of unit radius. And you know the equation of the sphere is like this, and C is its boundary. And the boundary is a circle in xy plane, and the radius is unit. And the center is at origin. Okay. Now we have to write the parametric equation corresponding to this circle C, and that is x cos t, y sin t, and z equal to 0, and t varies from 0 to 2 pi. Then using this equation, the closed line integral of a vector along the circular path will be of this form. Then after doing the integration and putting the limits, we get this value pi. Here in the integration, two parts are there. if we multiply minus sin t, then first part is minus 2 cos t sin t, which will give us minus sin 2t. Then after integration with limits, that will give us 0. Then in the second part, this is plus sin square t. So after integration and putting the limits, it will give us pi. Okay. So this is very straightforward calculation, you can do it. So we obtain the closed line integral value as pi. Now we have to show the surface integration of curl of a vector will be also pi. Then only we can tell the Stokes theorem will be verified, right? So for that, first we have to calculate the curl of a vector. And if we do the calculation, it will give us k cap. Next, we have to evaluate the elemental surface area ds in terms of elemental area on xy plane by the concept of taking projection of ds on xy plane. And k cap dot n cap ds will be dxy, which is this elemental area on xy plane, right? Then surface integration of curl of vector field A takes this form. This is the surface integration on this region R on xy plane, right? Now here x varies from minus 1 to 1 and y varies from minus root over 1 minus x square to plus root over 1 minus x square. Now minus root over 1 minus x square is this region of R, this left side region, and plus root over 1 minus x square is this right side region. Okay. Then after changing the limit, we get this integration form. After that, doing this integration with respect to y, we get this form of integration where x as variable, right? Now, if you consider x equal to sin theta, then you can easily solve the integration and we get the integration value as pi. Now, this is the same value you obtain from closed line integration of vector field A, right? So, Stokes theorem is verified for this particular situation, right? So, that's all about Stokes theorem. In the next class, I shall discuss about Green's theorem in plane. Okay. So, thank you for attending this lecture. See you in the next class.